So one of the wonderful challenges about astronomy is that we have to imagine something so we can go look for it. But nature has this way of being even more creative than we are. So we have always been surprised by what we see in the sky. That's why building a telescope has always been interesting. Every time we build a better one, we see something we never imagined was out there. That's been going on for centuries. This is the next step in that great series of a bigger, better, more powerful telescope that will surely surprise us in some way that I can't tell you.
So the James Webb Space Telescope at its core is designed to answer some of the biggest questions we have in astronomy today. And these are questions that go beyond just being science questions. They're questions that really get to the heart of who we are as human beings. Questions like, where do we come from? And how did we get here? And of course the big one, are we alone? To answer the biggest questions in astronomy today, we really need a very big telescope. And the James Webb Space Telescope is the biggest telescope we've ever attempted to send into space. It really sets us up with some really big engineering challenges.
It had never been done before to build a big unfolding telescope in space, because we knew we needed something that was bigger than the rocket to achieve the scientific discoveries that we wanted to make. We had to invent a new way to make the mirrors, a way to focus it in outer space, several new kinds of infrared detectors. We had to invent the big unfolding umbrella. We call it a sun shield.
Webb has 4 broad science goals: to detect the very first stars and galaxies that were born in the very early universe. So this is a part of the universe that we haven't seen at all yet. We don't know what's there. So the telescope, in a sense, is going to open up this brand new part of the universe, the part of the universe that got everything started. To search for the first galaxies that were born after the Big Bang.
The first stars and galaxies are really the big mystery for us. We don't know how that happened. We don't know when it happened. We don't know what those first stars were like. We have a pretty good idea that they were very much larger than the sun and that they would burn out in a tremendous burst of glory in just a few million years.
To watch how galaxies grow and change over time. We have questions like how galaxies merge, how their black holes form, and how gas inflows and outflows affect galaxy evolution. But we're really missing a key piece of the puzzle, which is how galaxies got their start. To find stars and planets born inside dusty clouds, and to help in our search for life in the universe.
So astronomy is one of the most observationally based sciences we've ever had. Everything we know about the sky has been a surprise. The ancients knew about the stars, but they didn't know they were far away. They didn't know that they were like the sun. Eventually we found that our own galaxy is one of hundreds, billions of galaxies, and that the universe is actually very old, but not infinitely old. So that was a big surprise too. Einstein thought, of course, the universe must have an infinite age without a starting point. Well, he was wrong. So our intuition has just been wrong almost all the time. We're pretty confident that we don't know what we're going to find.
As an astronomer, one of the most exciting things about working on a telescope like this is the prospect of what it will tell us that we haven't even thought of yet. We have all these really detailed science questions that we'll ask, that we know to ask, and that we'll answer. And in a sense, that's what science is all about. You know, in answering the questions, we come up with more questions. So there's this almost infinite supply of questions, of things that we have to learn. So that's why NASA builds telescopes, is really to get to this fundamental part of who we are as human beings. You know, we're explorers, and we want to learn about what our universe is like.